Okay, hey everybody. Um, New video, haven't done it in a while. This video is on B segmentation round 2. So, if you remember, if you've looked at any of my videos, you may have seen a video about B segmentation earlier in the year or late last year. This was based on an image SC question. A researcher was very kind to share really awesome images of a bee, which were great for testing deep learning on. Bees, not just one bee. Let me see here. Yeah, so here's the image of the bee. If you want to follow up on bee segmentation part 1, best place to start is to go to image.sc, search for how to count bees, and you'll find the links to the first videos, the code, and some of the early models. And I'll also put this video or these links in the YouTube comments. So this is bee segmentation round 2. And the focus here is going to be how to retrain when a new image is available. So hopefully this will be relevant to lots of problems, not just bees. So we're going to talk about how to retrain and a little bit about augmentation. And another really important thing that I hope this video makes clear is the difference between test, validation, and self-prediction. Okay, those are really, really important terms. So a test prediction or unseen prediction is the result of testing your model on an image that neither yourself, the AI engineer, nor the model has ever seen before. And so an image is only really a test image once, because once you bring it in, once you run the AI on it, you've seen the problems, and even if just subconsciously, you're going to start to address those problems, even if you don't feed the image back into the model. Validation. So after you've seen the image, you sort of maybe start thinking, okay, I see what the problems are with this image. But before feeding that image itself into the model, it's a good idea to try to see if you can solve the problems with that image just by, addressing perhaps some weaknesses in your training process. And we'll show a concrete example of that in this video. Then finally, there's self-prediction. So self-prediction is the result of running the model on an image that the model has already seen. And self-prediction is dangerous because you're going to get results that are too good to be true. But it's also very useful because it's a good way to verify that there's no wiring problems in your training process. Because you should, if you're not seeing too good to be true results on when you're predicting on images the model has seen, there might be something going on with with either your normalization or something else in your training process. Okay, so how do we train a new image? New image comes in, what do we do? Well, the first thing we do is we predict. Okay, so the new image comes in. I think this is the old B image, then the new B image came in. They're a little bit different, brightness, contrast, some of the color levels look a little different to me. So what happens when we run our model? This is the test. I'm using a model that has never seen this image, and it was trained before I ever saw this image. So let's see what happens here. Let's run it, and it should only take a few seconds to run. Let's see. There we go. Okay, so what's going on here? Looks like there's a bunch of bees showing up where there are no bees. Okay, now let's start up Napari. Napari is a really awesome viewer. It's a 3D viewer, but it's also really good for 2D machine learning problems because it has really good labeling functionality, really good zoom and pan functionality. Um, so there's some cool things in Napari. For example, you can look at labels as like solid uh, labels and adjust like the transparency, the opacity, to see what's underneath, or you can make them into contours. So there's lots of really good visualization tools. You can turn labels on and off, which is kind of useful. So Napari is great for both labeling and viewing your results. And what do we have here? So here's our big problem here. It's detecting stuff where there really are no bees. Okay, so bees where there are no bees. What do we do about this? So looking at this, it gets me thinking. It looks like there's a problem with the background. So perhaps the model has not seen enough like intensity variations in the in background. So it's coming up with false positives. So that gets me thinking that maybe augmentation would be a good way to deal with this. And this is my point about how a image goes from being test to validation. Because see, I know what's going wrong. So even if I don't feed this into the model, I'm still using the information and I'm thinking, augmentation, that's what's needed for this one. Okay, so let's go back to our workbooks, and we've got an augmentation workbook. So what I'm going to do here is I'm going to load some previous labels. Now these labels aren't from the new image, but they're from the old image. So they're pretty good, but there's actually, looking back on it, there's a couple of little mistakes that I didn't notice. So before working with this older image, I'm going to do a couple of corrections. So let's load up Napari again. There it goes. Okay, this is our original image. The model has been trained on this, and there's actually, even in this one, there's a couple of fake bees, which I guess I missed before. So what I'm going to do here is Napari is really great for this kind of stuff. We can erase the fake bees. There's one fake bee. To go back to pan and zoom, and another fake bee. Yeah, let's see. Okay, so yeah, I stopped the video for a second while I searched around for more fake bees, because you don't need to watch me searching for fake bees for 20 minutes. But anyway, we've made some corrections, and I keep emphasizing, this is the first image. We still haven't even gone into the second one yet. Turn off Napari again, and then what I'm going to do is, okay, notice here, I had some fake bees. Then I'm just going to replot just to make sure that the fake bees are gone. So this is really cool. So this is what you do in Napari is actually reflected in your Python environment. So you pop up Napari, you make changes to your label image. Those changes automatically, you're actually changing the array of the original image, and that's really good. So then we do a little bit of normalization here, and we augment the labels and the image. Okay, so what is augmentation? This is what it is. We get a bunch of images. We have all these little images are made from the original one label image. We just like crop, resize, recolor, a bunch of like patches for it to train. So now, remember I said that I thought we were getting fake bees because there wasn't enough variation in the background for our training set. So now I've used augmentation to create like a much larger training set with all kinds of variation in the background. Hopefully this will make our model more robust to those kind of errors. So yeah, so let's go back to our prediction. And what I'm going to do now, I'm not going to do the training during the video. It's not too bad. Even on a gaming GPU, it takes less than an hour. But again, I did it beforehand. So this this second model, the first model was the one from December, I think it was. This second model is the one using augmentation. So notice there's a bunch of fake bees, but let's run things again. Here we go. It's pretty fast. Nice. No more. Well, there are still a couple of fake bees, but the fake bees have been greatly reduced. So we're doing pretty good, but there's still some mistakes. Okay. Remember I said there's three sort of like categories of verification. There's test image, validation image, and then there's like this self-prediction. So this is the final stage. So we've done the we've turned this image from a test to a validation, and now we're going to make it we're going to sort of self-predict on it. So what we're going to do is we're going to go back to our augmentation, and we will simply feed the new image into it. Okay, so you probably saw an error pop up, and I paused the video. I just forgot to save the new labels from the second B image. So we do the same thing with these guys. We open it up in Napari, and there's a few fake bees I think in this one still. So we erase them again and everything. That's great. I did this previously, so I won't go through the whole process, but you get the idea. Like if you're doing this for real, not just for live in a video, you spend, you take care, you spend a few hours on it. You could even get a team of people to label bees all day and correct them. You get the idea. But yeah, so we go through this, we augment again. So from this second B image, we make a bunch of augmented, rotated, recolored B images, and then we train a third model. So the third model, let's go up here. So third model, I think I called it Model Uber, is trained on both B images. And that model should perform the best. So what I'm going to do here is I actually have another notebook which is going to load the results from all the models. Okay, so I paused again because this took about 30 seconds 27 seconds actually to generate all this, but I want to keep the video short. I haven't actually paid for the paid version of the video recorder, and not just because I'm cheap, but it's like you're limited to 15 minutes, and I think that's a great length for videos. If I trying to keep them under 15 minutes because I think that's if they get too long, nobody pays attention. But anyway, so what I've done here is I've done 3 different predictions, and it's probably cool to see them in Napari. Great thing about Napari is just the ability to turn these guys on and off. So we can really look at what's going on individually with each set of labels. So we have our bees here. This is the unseen prediction. That is the old model from December where we had a bunch of fake bees in our image. The second one is the tune prediction. This is we did not train on this image, but we used information on how our model was performing on this image to tweak our training process, mostly augmenting and getting more background areas. So now we've gotten rid of a lot of the fake bees, but not all. And then the final one is self-prediction. So this is the final step where we fed our image into the model, and the model has seen this guy. And this is the too good to be true. So I'm quickly running out of time, but if we look at this, you could see it's finding like all kinds of subtle little bees, and that's just because it's seen this image before. Yeah, so be careful with this one. Maybe too good to be true. Anyway, thanks for listening to my video. And I think we're out of time now. Okay. Wow, apparently it's allowing me to go past 15 minutes. Well, I'm going to talk for another hour. No, I'm just kidding. What I'm going to do here is just quickly finish off what I was talking about, the difference between the tune prediction and the self prediction. So if we look at the tune prediction here, remember this was trained using knowledge of this image, but not the image itself. So it's actually doing pretty good, catching most of the obvious Bs. Now look at the self prediction. It's almost incredible. Like it's finding like little subtle parts of Bs here and there. So now maybe if you trained models on tens of B images, maybe even hundreds, you would start getting this kind of performance on like unseen data. But yeah, always use this type, interpret this type of result with just a bit of caution. Okay, so now I think the video is over for real. Thank you very much.